Hey Portable 4, here's a little review of some of the concepts we've been doing in geometry. It's mostly about area and how that area of different 2D shapes turns into surface area and eventually volume of 3D shapes. So let's start off with the area of a rectangle. Pretty straightforward. You've got the length of the rectangle and the width. You multiply the two together. So length equals, area equals length times width. Not a great start. Same with a square. The square is also length times width. But of course, when we know in a square is the length equals the width because it's a square. So really, as long as you know one of the sides, you'll know the dimensions of the square. So also the area also equals length times width. Let's talk about the area of a triangle. It's a little more funky. Let's pretend we were talking about this rectangle again. If I do a straight diagonal here, and cut this rectangle in half, I'll end up with two triangles that are exactly the same in terms of the area. So if the area of the rectangle equals length times width, then the area of each of these triangles is really the length times the width divided by 2. That's the basis of the formula for a area of a triangle. However, because in some situations, you might end up with these funky triangles, this obtuse triangle here, where length and width kind of are hard to see. So we change it into the base. We change it to the base, and we instead of the length and the width, we go by the height. So it's really the the area equals the base times the height, and that's all divided by 2. Or you can multiply it by half, either way. So in triangles, a little funky. You have to find the base and the height, and then you divide that by 2. Now here's a concept for the grade 6s only, the area of a parallelogram. So let's just draw a little parallelogram here. Now, in order to think about this, let's pretend we are able to cut this little triangle off of the parallelogram and we move it over to here. In that case, the resulting rectangle here, I'm going to just try to make it bolder. If we find the area of this larger rectangle, then we really found the area of the parallelogram. So for this parallelogram, for the area of this rectangle, it ends up being, again, the base here times how high this is. So a parallelogram is also base times height. So the area for a parallelogram is the base times the height. Base times height. Same as for a triangle, except you have to divide by 2. So that is all the areas, the formulas you need to figuring out the basic shapes and their areas. On the next activity of the review sheet, on page 2, it looks kind of like this, and it's more all about identifying the different types of nets. If you have a 3D shape and you take it apart and fold it flat, these are the nets that you would end up creating. Some of the nets end up being for the prisms, and some of them ends up being for the pyramids. Usually for pyramids, you're going to see a lot of triangles. And in the prisms, at some point, you're going to see some squares and rectangles. Typically, let's take a look at this guy here. This has got two pentagons and then 5 sides, and that will fold up into a pentagonal prism here. I usually like to think about shapes in this way. Like you've got this band of shapes that go around the middle, and then you've got the two shapes that are on the end. And when I usually can think about it that way, it's a lot easier to think about the nets for me. Here's another example for a triangular prism where you've got the shapes that form the band, and then you've got the 2 end caps along here. Here's an example of the pyramids, and pyramids, all with different shaped bases on the bottom. Okay, so part of the test for grade 5s and 6 will be, there will be some nets there, and you'll also have to draw some of the nets. On this type of paper, you would end up drawing a net. You would end up drawing either what a cube would look like and a rectangle. The other thing you got to watch out for with nets, although this will totally work, of course, this shape could be here or here or here or here. There's lots of ways that these shapes can be combined. So you have to kind of think about folding it up in your mind and seeing if some of the shapes will actually work or not. Here's another example over here where a hexagonal prism, so they have made it totally different where all the shapes are coming out from around one of the ends. Just keep in mind that there's different ways of drawing it basically. Oh, like I said, on this sheet you'll be drawing some of the shapes, and we've done that. I might also say, draw a net with a surface area of a certain amount. Let's get to two grade 6 concepts, and that is the surface area of these shapes and eventually the volume. This part can be a little bit tricky because surface area is one thing, and of course volume is something else. Surface area really is all of the space around the outside of the shape, the material it takes to make that shape. And in my review sheet, you might not notice that, but these kind of go together. Here's the shape, and here's what the surface area would be. Now, the good thing about surface area is we already know area. If you look at this, let's pretend this is a tissue box on its end. You basically have just a series of rectangles. And the thing about a tissue box type of a rectangular prism is there's these shapes that match. So this one matches there, this matches there, and this matches there. So there's 3 pairs of shapes in a rectangular prism. And then we just kind of work out what the dimensions of each of the different rectangles are, and then we add it all up. So for example, in the end parts here, it's 2 by 1. So 2 by 1, that's 2 centimeters squared and 2 centimeters squared. In this shape here, it's 1 by 3. So 1 by 3 is 3 centimeters squared, and the other one is 3 centimeters squared. And finally, the largest shape is 3 by 2. That's 6 centimeters squared. So we got 6 centimeters squared and 6 centimeters squared. Now, I haven't done a really good job of organizing this in the limited space, but what I would do then is I would add up. So it's 2 times 6 centimeters squared and 2 times 2 centimeters squared and 2 times 3 centimeters squared, and you would add all that up, and that would give you the total surface area. So what you're doing is how much space is contained inside this. When you think about it as just a series of rectangles and squares and triangles added together, it's a little bit easier to kind of work that out. One of the tricks for a cube with a net is because each one of these are the same, it's going to be, as long as you figure out what one of them is, then you can multiply it by 6. In this instance, it's a 5 by 5. So 5 by 5 is 25 centimeters squared times 6, which would be on the spot, I think, 150 centimeters squared. Make sure you get the units right on that one. The triangular prism is a little bit of a tougher one. You end up having 3 rectangles here, which are 5 by 4. So that would be 5 by 4 is 20. So that's a 20. That's 20 centimeters. That's 20 centimeters squared. But then you have these 2 triangles. The 2 triangles have a base. In my quick diagram, it's probably not. It's not to scale, but let's work with this. 4 centimeters for the base, 3 for the height. So 3 times 4 is 12. But I'll have to multiply by a half as well, or divide by 2. Because this is only half of the area triangle. So that really gives me a 6 here. So this is a 6 and this is a 6. So in this case, I've got 20, 20, 20, which is 60, plus 2 6s, which ends up being 72 centimeters squared. So the steps really are to calculate all the area for all of the different shapes that are in the net, and then finally to add them all together. And that gives you the area, the surface area. Let's now go down to the volume. And for the volume, let us draw a little, I like to draw a little diagram for the volume. So here's my rectangular prism. Not a great drawing, but you get the idea. What I like to do is figure out what the area is of one of the sides and then multiply how long it is. So in this case, we have how high the shape will be, the the width and the length. So h times L multiplied h times W times L will give me the total volume of the shape. So the volume equals the height times the width times the length. So the 3 dimensions will give me what the volume is of any of the rectangular prism and also the cube. Again, the cube is a little bit easier because if it was 5 by 5 by 5, you know, it's really like 5 times 5 times 5, or it would be 5 cubed if you want to get fancy. Now let's go to what the volume is for a triangular prism. And I think this is the toughest one for kids so far I've seen. So the way I think about this is if I can calculate the area of this end triangle, then I just multiply by how long the shape is. So again, I calculate the area of the end triangle and then multiply how long it is, and that will give me the volume of that. So in my little diagram, h equals 3, and we have 4 centimeters here, and the length is 5 along the side. So I first figure out what is the area of that end cap, that end triangle, and that's 3 times 4 divided by 2. And then I calculate how long that is, which would be, and then times 5. So for this one, it would be 12 divided by 2 times 5. And that would be 12 times 2 is 6, so 6 times 5, and that would equal 30 centimeters, not squared, it's cubed this time. So watch out for the volume, the unit, 30 centimeters cubed. That's the way I do the volume of a triangular prism. Find the area of this and then multiply it by that. And I use the area of a triangle formula for that. One other thing that's not on here that we talked about briefly is the difference between the volume, which is measured, volume is measured in centimeters cubed, but the capacity is defined as something else, and it is uses the units milliliters. But luckily, 1 milliliter equals a centimeter cubed. So if you calculate the volume of something, you can translate that into capacity by just changing it into milliliters. So if they ask for the volume of something, you would say, I calculated it as 30 centimeters, but if you say, what's the capacity, how much can it hold, you would end up saying 30 milliliters, just do a change of the units. Okay, so that, I think, is everything for the most part from the review sheets that I did. I'm going to write this more as an EQAO style test because we only have 1 month before our EQAO test. So you should also be reviewing this video, hopefully, the review booklet I gave you, and the extra work we did from EQAO, which is in your white folder. Good luck, everybody.